Hi, Mrs. Maholchek here. So we're going to cover another problem. This problem covers filling in tables and writing exponential equations for those tables. So for this one, when reading the directions, it says complete the table and write the explicit equation for the exponential function. Please notice that it's an exponential function. When we talk about exponential functions, we're talking about multiplying by the same number every single time. So remember, linear functions, they add or subtract the same number every time. And then exponential functions, they either multiply or divide by the same number each time. So we're going to go through and fill in the table first, and then we will write the equation for it. So we have an XY table here. It's getting horizontally instead of vertically. So the X values are labeled on the top. The Y values are on the bottom. So the Y values are what we have to fill in. The X values, as you notice, it starts with 0 and ends at 2. But there's several spaces in between each whole number. So these are actually going by 1/3 each term. So it's 0 plus 1/3 is 1/3, plus 1/3 is 2/3, plus 1/3 is 3/3 or 1. So each space is going up by 1/3. So knowing that it's an exponential function and knowing that we're going to have fractions here in our exponent, we know we're going to need radicals. So first what we need to do, let's fill in the table from the whole numbers. So x, when x is 0, 1, and 2, let's fill in those. So we know when x is 0, y is 2. When x is 1, y is 4. So you want to find out between whole numbers, what was the jump we made? What did we multiply by? So from 2 to 4, we had to multiply by 2. So for multiplying by 2 every whole number, 0 to 1, from 1 to 2, we're going to multiply by the same whole number. So 4, we're going to multiply by 2. That's how we get 8. So the first step is to go ahead and fill in the whole numbers for the y values when x is 0, 1, and 2. After that, what we want to do next is find, well, these terms are going by 1/3 each time. So there's 3 parts. So we have to know what do we multiply by each time to fill in these smaller third of a term. So from 2, we have to multiply by something to get the third of a term. So what you do is, I'm going to go ahead and move this up. So we know the whole jump from 0 to 1, the whole jump is 2. But we have 3 small jumps in between. So there's got to be some number that multiplies by itself, because remember, exponential means it's multiplying by the same number every time. So we have to find some number that multiplies by itself 3 times to equal a whole jump of 2. So thinking about what we know about exponents, we can say that it's 2 to the 1/3 times 2 to the 1/3 times 2 to the 1/3. Because when we have bases with powers, if the bases are the same, then we keep the base and then we add our exponents. So it's 1/3 plus 1/3 plus 1/3, which equals 2 to the 3/3, or 2 to the 1st, which is 2. So another way you can find this out is by taking, and this will work every single time, is to take these steps. This is the radical. So you know you're going to be multiplying by some radical here because we're going to have fractions in our exponents. So in the radical, the number that goes inside, the radicand, is always the whole number multiplier. So what are you multiplying by between whole numbers, 0 to 1, 1 to 2? We said we were multiplying by 2. So that would be 2 inside. Also, the index, this number here, that's always going to be the number of small jumps between whole numbers. So the number of small jumps between whole numbers. So our index is how many jumps does it take to get from each whole number within those small jumps in between. So from 2, it takes 1, 2, 3 times to get there, so our index would be 3. So it's going to be the third root of 2 is what we're multiplying by every third of a term. And you'll notice that that equals 2 to the 1/3 power. If we write 2 to the 1/3 as a radical, remember our base becomes our radicand, what's inside. Our numerator 1 becomes our exponent, and our denominator 3 becomes our index. So third root of 2 to the first power, that's just 2, is the same thing as third root of 2. So every little mini jump we do, every third of a jump, we're going to be multiplying by the third root of 2. Again, by the third root of 2, and again by the third root of 2. So going back up to our table, if we multiply 2 by the third root of 2, we can't put those together. 2 times the third root of 2. Because 2 does not have a radical, you cannot combine these. You cannot combine these, so you just leave them as multiplying. So 2 times the third root of 2. However, when you take that number, 2 times the third root of 2, and you multiply by the third root of 2, again, so I'm going to come down here. So we take 2 times the third root of 2, multiply